My name is Rizwan bin Norman. I am from Group B6 and today I'm going to be presenting about the chapters Software Verification and Validation Concepts and also Software Testing. Okay, now let's begin. For introduction, the quality of product and processes are needed to build high quality systems. Therefore, the techniques to ensure a high quality software are verification and validation. Verification and validation is a system engineering discipline that uses a strict methodology to evaluate and rate the accuracy and value of software at every stage of the software lifecycle. The objectives are to evaluate the system's utility and suitability for usage in a practical setting and to identify system flaws. Both should establish confidence that the software appropriate for the purpose of software purpose, user experience, and marketing environment. For the benefits of verification and validation, early flaws detection leads to better solution compared than quick fixes. Validation of the solution is solving the right problem against software requirements. Objective evidence of software and system compliance to quality standards. And lastly, it supports process improvements with an objective feedback on the quality of development process and products. Okay, for its field of application, it is important to conduct verification and validation in its interactions with the system of which it is a part of. It also examines the interactions with each of the key system components. The verification and validation process addresses the following interactions with software environment, operators and users, hardware and other software. This is the graph for V&V and planning process. Verification and validation is an expensive process, so a careful planning is needed to get the most out of it and to control the cost of the process. This is because it is a whole life cycle process. It is a balance between static and dynamic, and it draws up standards for inspections and testing. This is the structure of test plan. For the test plan, we are going to implement the questions how, why, what, and when. Okay, for cost and methods, the rule of thumb for estimating verification and validation effort ranges from 10% to 33%, depending on the software integrity level. For nuclear or medical devices, it is a steady 33%. For telecoms or financial systems, it is less than 25%. For systems desiring software quality but not high integrity, it is less than 18%. It's used these techniques to verify the software during its development process, which is by using static, which is analytic technique, and dynamic. Static techniques, it is a review of requirements, designs, or code characterized by the author of the material under review, guiding the progression of the review. It is conducted by peer review or desk check, which is only one person examines the reviewed product. Another technique is technical review, which is a group discussion activity that focuses on achieving consensus. Another technique is inspection, which is a group review quality improvement process for written material. And the last one is audit, a process to evaluate a software product against the specified and established standards. Analytic techniques for static analysis of the software is by using graphical, math formulas, or diagrams. It is very effective in detection of the error at the software unit level diagrams. For example, techniques like control flow diagram, interface input/output/process diagram, algorithm and equation analysis, database analysis, sizing and timing analysis, and proof of correctness. Okay, moving on to dynamic technique. It involves the execution of the software. It is very effective at the error detection when software units are combined at the integrated subsystem and system level. The techniques utilizes simulation and modeling, hard or software benchmark testing, hardware in-the-loop testing, and also scientific testing. For software testing automation, The use of software to control the execution of tests, the comparisons of actual outcomes to predict the outcomes, the setting up of test preconditions, and other test control and test reporting functions. The framework consists of data-driven testing, modality-driven testing, keyword-driven testing, hybrid testing, and model-based testing. Okay, finally, test-driven development. It is an approach to program development in which you interleave testing and code development. It is written before code. You don't move to next increment until the code passed its test. It was introduced as part of agile methods such as extreme programming. Okay, that's all. Okay, now let's proceed to the next chapter, software testing. Software testing is a process of exercising a program with the specific intent of finding errors prior to delivery towards the end user. Their objectives are to lead to validation testing, to lead to defect testing, and a successful test is one that discovers an as yet undiscovered error. Let's go to principles of software testing. All tests should be traceable to customer requirements. The test should be planned earlier on early stages. The Pareto principle should be applied. Testing should begin small and progress to larger in time. Exhaustive testing is not possible. Testing by independent third party is the most effective. For testing, it is a dynamic technique that requires execution of executable system or unit. The test case requires certain stimulus composed of name, input, and expected output. For good test case design, it has a reasonable probability of catching an error. It does interesting things, it doesn't do unnecessary things, it is not neither too simple or complex, it is not redundant, it makes failures obvious, and it is mutually exclusive, collectively exhaustive with other tests. Software testing process. This diagram explains the software testing process. The goal of defect testing is to expose latent defects in a software system before the system is delivered. Moving on to stages of software testing. It begins with development testing, which system being tested during development process. And then release testing, a separate testing team tests the complete version of the system. And lastly, user testing, when a user tests the system when they start to use it. Other types of tests include unit, which is individual classes or types, component, which group of related, and integration, which is interaction between classes and modules. Development testing. Unit testing, which is the process of testing individual components in isolation, uses the concept of black box, which is functional, and white box, which is structural. Component testing is where several individual units are integrated to create composite components. System testing is where it involves integrating components to create a system. For unit testing, it's a process of testing individual components in isolation. It is also to defect testing process. Units may be individual functions or methods within an object. The object classes with several attributes and methods. Composite components with defined interfaces used to access their functionality. Testing effectiveness. If there are defects in the components, this should be reviewed by test cases. It may lead to two types of unique test cases. First, what the system should do. The first of these should reflect normal operation of a program and should show that the component work as expected. Second is what the system shouldn't do, which is the other kind of test case should be based on testing experience of where common problems arise. It should use abnormal inputs to check that these are properly processed and do not crash the system. Unique testing strategy, it consists of two methods. First of all is partition testing, where you identify groups of inputs that have common characteristics and should be processed in the same way. Second is guideline-based testing, where you use testing guidelines to choose test cases. Next, for testing guideline sequence, test software with sequences which only have a single value. It must use sequences of different sizes in different tests. Derive tests so that the first, middle, and last elements of the sequence are accessed. Tests with sequences of zero length. For general unit testing guidelines, first, we must choose inputs that force the system to generate all error messages. Second, we must design inputs that cause input buffers to overflow. Third, repeat the same input or series of inputs numerous times. Fourth, force invalid outputs to be generated. And lastly, force computation results to be too large or too small. Next is component testing. Software components are often composite components that are made up of several interacting objects. You access the functionality of these objects through the defined component interface. Testing composite components should therefore focus on showing that the component interface behaves according to its specification. The objectives are to detect faults due to interface errors or invalid assumptions about interfaces. Interface types are: first, parameter interfaces, which are data passed from one method to another. Second is shared memory interface, which is a block of memory is shared between functions. Third is procedural interfaces, which subsystem encapsulates as a set of procedures to be called by others. And fourth is message passing interface, which subsystems request services from other subsystems. So, for interface errors include interface misuse, which is a calling component calls off another component and makes an error in its use of its interface, such as parameters in the wrong order. Next is interface misunderstanding, which is a calling component embeds assumptions about the behavior of the called component which are incorrect. Third are timing errors, which are the call and the calling component operate at different speeds and out-of-date information is accessed. System testing, which is development, it involves integrating components to create a system or subsystem. It may involve testing an increment to be delivered to the customer. There are two phases involved. One is integrated testing, which the test team has access to the system source code. The system is tested as components are integrated, from which the two methods arise, which is top-down, which stimulates a not implemented component, and bottom-up, which drives a not implemented component but drives the subcomponents. 2 is release testing, in which the test team tests the complete system to be delivered as a black box. For use cases, it can be a basis for deriving the test for a system. They help to identify operations to be tested and help design the required test cases. Other system testing include recovery testing, which is to check systems' ability to recover from failures. Security testing, which verifies that system protection mechanism prevents improper penetration. Stress testing, which program is checked to see how well it deals with abnormal resource demands. Another one is performance testing, which tests runtime performance of software. Lastly is user testing. User testing is a stage in the process where customer provides input and advice on system testing. There are 3 types of user testing, which are alpha test, which is test with development team, beta test, which is a test by the user alone, and user accepted test, which is test at user side. Okay, that's all from me. Thank you.